Assalamualaikum and hi everyone. Today we are from Group O. We'll explain to you about the triple integral in cylindrical coordinates by using Divergence Theorem or known as Gauss Theorem. But first, let me introduce you to our group members, which are Nurul Aini binti Ngatani, Nurul Diana Fadilah binti Jamaluddin, Nurul Najwa Najiha binti Zahrul Nizam, and Nur Fatihah binti Mat Fadel. Divergence theorem is also known as Gauss theorem, which relates the flux of a vector field through a closed surface to the divergence of the field in the volume enclosed. We could calculate the surfaces integrals of each surface respectively, but the calculation might be tedious. Hence, we need to apply divergence theorem for the flux integrals of a closed-oriented surfaces. By referring to the formula given, instead of using double integral, we could evaluate the surface integral of a vector fields by using triple integrals, provided the solid is a closed solid. We will explain to you guys about the divergence theorem with given examples of questions and solutions after this.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Fatihah binti Mat Fadil from Group O. I would like to present for next example question for division theorem, or also known as Gauss theorem. So the question is, calculate double integral of f dot ds where f equal to 3xy squared, x exponent the power of z, and z the power of 3. So S is the surface of the solid bounded by the cylinder, y squared plus z squared equal to 25, and the planes x equal to -4 and x equal to 3. So the flux integrals often expressed in one of these form, which is equal to the triple integral over the region V of the division of the vector field f dv, which is also can be expressed in this form. So for the solution is f equal to 3xy squared sp, and x exponent the power of z is q, and z the power of 3 is r. So the partial differentiate of p respect to x is 3y squared, and the partial differential of q respect to y is 0. Partial differential of r respect to z is 3z squared. So because the surface is cylinder, and notice how cylinder is running along the x-axis and is bounded at x equal to -4 and x equal to 3. So the differential b dv is not equal to r dz dr d theta, but it will equal to r dx dr d theta, because the cylinder running along the x-axis, where the y squared plus z squared is equal to r squared. So this triple integral will equal to triple integral of 3r squared r dx dr d theta. So we will integrate with respect to dx with the triple integral with limit -4 to 3, 0 to 5, and 0 to 2x, and 3r power of 3 dx dr d theta. We integrate with x, so it become the limit of 0 to 5, 0 to 2 pi, 3r power of 3 multiplied by x, limit -4 to 3 dr d theta. Then we substitute the limit into the equation. We get the limit is 0 to 5, 0 to 2 pi, 3r power of 3 multiplied by 3 minus 3r power of 3 multiplied by -4 dr d theta. Then we get the value is 21r power of 3 dr d theta. Then we substitute in with respect of dr. So the limit is 0 to 2 pi and 21 over 4 r power of 4, and the limit is 0, 5. So then we substitute the limit into the equation with limit is 0 to 2 pi, 21 over 4 multiplied by 5 power of 4 minus 0 d theta. Then we get the value, which is 13125 over 4 d theta, and we integrate with the respect of theta, and it becomes 13125 over 4 multiplied by theta with limit 0 to 2 pi, and it becomes 13125 over 4 multiplied by 2 pi over 1, and this is the same vector, so we can cross out and it becomes 2 and this becomes 1. So the answer is 13125 pi over 2, which is represent the total flow across the boundary of surface S, as well as the total divergence of the vector field.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nurul Aini binti Ngatini. I would like to present about triple integral in cylindrical coordinates. So, in this topic, we need to find the volume of the solid by using triple integral in cylindrical coordinates. The polar coordinates specify the location of a point using the distance from the origin and the angle formed with the positive x-axis when traveling to the point. Cylindrical coordinates are rectangular coordinates r, theta, and z in 3 dimensions with xy plane in polar coordinates. To find a point r, theta, and z in cylindrical coordinates, we need to find the point r, theta in the xy plane, then move straight up parallel to z-axis according to the third dimension given. Next, I will explain the question with the solution of triple integral in cylindrical coordinate. Okay, for the example 1 given, use the triple integral in cylindrical coordinates to determine the volume of the solid bounded by z equal to 0 and z equal to 9 minus x squared plus y squared. Okay, firstly, we need to sketch the line of the graph, which is xy trace equal to x squared plus y squared equal to 9. After that, we need to sketch line xz trace, z equal to 9 minus x squared, yz trace, z equal to 9 minus y squared. Okay, in this question, we need to use the cylindrical coordinate, which is x equal to radius cos theta, y equal to radius sin theta, and z equal to z. So we get the x squared plus y squared equal to radius squared, x squared plus y squared equal to 9. So we get the radius equal to 3. After we get the limit of the r, we need to find the limit of z and theta. So we get the z equal to 0, 9 minus r squared, pi 0 and 3, theta 0, 2 pi. So we get the dv equal to dz dy dx equal to r dz dr d theta. After that, we need to integrate 2 pi 0, 3 0, 9 minus r squared 0, then substitute r dz dr d theta. So we get the answer is integrate 2 pi 0, 3 0, r z integrate 9 minus r squared 0 dr d theta equal to integrate 2 pi 0, 3 0 multiply 9r minus r to the power of 3 dr d theta. Then we get the integrate 2 pi 0, 9 over 2 r squared minus 1 over 4, 3 0 d theta equal to integrate 2 pi 0 multiplied by 81 over 2 minus 81 over 4 d theta equal to integrate 2 pi 0, 81 over 4 d theta equal to 81 over 4, 2 pi 0. So just substitute 2 pi equal to 81 over 4 multiply 2 pi over 1 minus 0. So we get the 81 pi over 2.
Okay, hi. Next, I will explain a question of triple integral in cylindrical coordinate and show you the solution. The question is use triple integral in cylindrical coordinate to find the volume of the solid bounded by x squared plus y squared equal to 9, z square root 25 minus x squared, y squared, and x equal to 0. As you can see here, this is our solution. So firstly, the solid is the region G shown in figure A and its projection are on xy plane shown in figure B. The question is given z equal to k in bracket r theta equal to 0, and as we are using the integration, we can obtain z equal to k2 in bracket r theta equal to square root 25 minus r squared. Next, we can find the volume of solid bounds V, triple integral G, GV. The equation integral to 0 to 2 pi, 0 to 3 in bracket 25 minus R2, 1 over 2 R dr. So let's assume U equal to R2, du equal to 2 R dr, then 1 over 2 du equal to R dv. So we can substitute u in r square, then du to 2r dv, then 1 over 2 du equal to dr. Lastly, after we derive the equation, we can get a final answer is 122 over 3 unit cubic.
As a conclusion, divergence theorem is an important result for the mathematics of physics and engineering, particularly in electrostatics and fluid dynamics. That's all from us. Thank you for your attention.